Hello everyone. Today, Alper Demir, Oğuz, Kaan, and me, Ahmet Akbıyık, we are talking about the solar panel system, floating solar panel system. First of all, there has been a rise in demand for environmentally friendly energy sources throughout the world as the usage of renewable energy sources has increased dramatically over the previous decade. Photovoltaic panels, PV, are a type of renewable energy that is widely employed. Floating photovoltaic panels are considerably more effective and cost-effective variants of solar panel use. According to the several studies, since FPV systems are cooled by the reservoir, which boosts efficiency. The goal of this research is to show why floating solar panel could be considered for reservoirs, particularly in Turkey, by looking at evaporation and energy generation utilizing FPVs on the İTÜ Lake, which is located on Istanbul Technical University's Ayaz Ağa campus. Monthly wind speed, air temperature, solar radiation, elevation, and other environmental data are gathered using free source software, Solar GIS, PVGIS, and other resources. The monthly evaporation is then computed using the provided data and formulation. The amount and kind of solar panels to be put are determined by energy requirements. The remaining solar radiation that is converted to heat raises the PV temperature, increasing the energy production. Solar panels create power. Pontoons or floats maintain the panels above water. An anchoring and mooring mechanism keeps the panels in place, and an inverter completes the system. The cooling action improves panel efficiency while lowering evaporation from the reservoir surface. Studies conducted in Australia have shown that due to evaporation, 40% of the water in open reservoir is lost. Turkey has a lot of potential, and given the surrounding waters, it requires FPV systems. In Turkey, FPV is already being utilized on a modest basis. Büyükçekmece Dam hosts the installation. The FPV after briefly presenting the FPV idea, the formulation and results for evaporation and energy output are undertaken using İTÜ Pond as a reference point. Data corresponding to İTÜ Pond using a MATLAB algorithm. After that, several FPV kinds, such as off-grid, fixed angle, and tracking FPV systems are used to compute annual energy production.
Hi everyone, my part is to explain evaporation in MATLAB, how we print it into MATLAB, and we try to plot evaporation graph for İTÜ Pond, and Henman-Montet equation transpiration model is used for our monthly evaporation. KW is the open water coefficient, it is constant. Rn is their net radiation, and the other sources are also shown in our MATLAB code. And here it's our Excel table, which we are going to import into MATLAB. And we accepted this as the last day of months for a more accurate calculation, but they are actually mean value of months. Temperature values are gotten from Turkey meteorological site, and wind speed is taken as monthly mean, and global irradiation is approximately 4.2 kilowatt-hour per meter square, but we need megajoule per meter square, and we convert it into this type, and we have 15.2 global irradiance, and albedo coefficient we are gonna calculate for İTÜ Pond, so we take it as a lake, So this is 0.08. And in the MATLAB code, we have some changing values and some constant values, and we separated the code to two parts. And for the first part, we have to find the daily net radiation, and so we need to have RA, which is extraterrestrial radiation, and net long wave radiation. So firstly, to find RA, we need to have declination angle, distance factor, latitude and radians, and hour angle. And to find FCD to use in R and L, we have to define clear sky radiation, and then we found the cloudiness function to use it into R and L. And finally, in the part one, we found the daily net radiation to use in our evaporation equation. After that, in part two, we calculated average air temperature, atmospheric pressure, delta, which is slope of set saturation vapor pressure curve, and psychrometric constant, and solving for saturation vapor pressure, and heat flux density, which is 15% of and daily net radiation. And finally, we have our evapotranspiration graph and all the data. Then we plotted the graph as you see in the graph, and as you see, in summer evaporation increases, and in winter it decreases. And after that, we try to use this graph in for a protected amount of evaporation, and it is 33% of evaporation is prevented by floating solar panels, and the following figure is obtained like this. Assume in this figure, we assume the instant area as 2079 meters square, which is approximately 10% of Itoton. And my part is done. Thank you for listening.
Hi, my name is Alper. I will talk about the energy yield section. To make a realistic study, we considered IQ pond, but the overall pond area is small compared to a dam. Therefore, the energy production is expected to be low as well. For the calculation of energy yield, we considered polycrystal photovoltaic panels with a capacity of 280 watts. The panel area is chosen 2.5 square meters. The surface area of IQ pond is around 20,785 square meters. We wanted to prevent any damage to environmental and touristic activities, so we decided to use 10% of the surface area, as you can see in Formula 2. After determining the total panel area available, we calculated the number of panels by dividing and found 831 panels. We determined the quantity and capacity of floating photovoltaic panels, so we obtained power capacity of installation as 233 kilowatts. After calculating the power capacity of panels, the monthly energy output data for the corresponding coordinates and elevation is obtained from PVGIS. We obtained the monthly yields for 3 different photovoltaic systems, such as fixed angle, tracking, and off-grid photovoltaic systems. For every panel type, we assumed a 14% system loss. We obtained an energy yield of 1,278 kilowatt hour per year for fixed panel. After our literature study, we decided to consider a 10% increase of energy output because of the cooling effect. After including the cooling effect, fixed panel energy yield is found 1,466 kilowatts hour per year. You can see the monthly values in the figure. For the tracking panels, we assumed the same cooling and system loss. We obtained a yearly panel energy output as 1,841 kilowatt hour. You can see from the graph that the inclined axis option of mounting has a higher output. For off-grid PV system, yearly energy output with the same assumption is 2056 kilowatt hour. For our investigation, neglecting the maintenance and installation costs, it's observed that off-grid panel system has a higher energy output than tracking system, and tracking system has a higher output from fixed-angle panel systems. In conclusion, it is necessary to research on more effective and energy production methods in order to protect environment and provide energy demand of our society. Floating solar panels are therefore a necessity of our era. This study was carried out considering a small area of 10% of ITU pond due to the stated environmental reasons. Therefore, the energy produced and prevented evaporation volume was kept at a minimum. After our investigations, it was determined that there is a significant effect on both evaporation and energy production. Therefore, it is important to develop floating solar panel technology. Thank you for listening.